Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the derivative rules. So as per the problem, the tangent to the cubic function that is defined by y equals x cubed minus 6x squared plus 8x at point A, 3, negative 3, intersects the curve at another point B. And we have to find the coordinates of point B. So we are given the point at which the tangent touches this curve, the given curve. So the first step here is to find the derivative of this given function, the equation of the curve, to find the slope of the tangent. And we'll use that slope of the tangent to find the equation of the tangent. So let's start with the derivative of the given equation. So we can write y prime. So I'm using the prime notation, which will be equal to the derivative of the first term over dx and minus the derivative of 6x squared over dx and then the derivative of the third term, which is dx, 8x. Now we can use the power rule to find the derivative of the first term, which will be 3x squared. So we bring the exponent 3 to the front and we subtract 1 from the exponent. And minus, now we can use the constant product rule to bring the 6 out of the expression. So we get the derivative of x squared. And then now we have to find the derivative of 8x, so we can move the 8 in front of the expression. So d over dx for x. Now in the next step, we can use the power rule. So 3x squared, then we'll get 6, and then parentheses 2 times x, and then plus 8 times 1. The derivative of x is just 1. So we can simplify this expression as y prime equals 3x squared minus 12x plus 8. So this represents the slope of the tangent. Now the tangent touches this curve at point 3, negative 3. So the first step here is to sub in x as 3 to get the slope of the tangent. So we'll get 3 parentheses 3 squared minus 12 times 3 plus 8. So we get m equals 3 times 9 minus 36 plus 8. So now we get 9 times 3, which is 27, minus 36 plus 8. So this is equal to negative 1. So this is the slope of the tangent that touches the given curve at 3, negative 3. Now we can start with the general equation of a straight line, y equals mx plus b. Now the slope of the tangent is negative 1, so we get y equals negative x plus b. We don't write 1 as a coefficient. Now the point 3, negative 3 also lies on the tangent because the tangent touches the given curve at this point. So we sub in y as negative 3 and x as 3 and solve for b. So to isolate b, we add 3 to both sides. So the 3's on the right side cancel each other out and also on the left side. So we get 0 equals b. So the equation of the tangent is y equals negative x. Now we have to find the other point at which the tangent intersects the curve. So for that, we'll set the equation of the curve equal to the equation of the tangent. So we get x cubed minus 6x squared plus 8x equals negative x. So we have to solve this equation to find the value of x at which the tangent touches the curve. So the first step is to move the negative x to the left side of the equation and set the equation equal to 0. So we add x to both sides. So the x's on the right side cancel each other out. So we get x cubed minus 6x squared plus 9x equals 0. So now we have to solve this equation. So the first step is to do common factoring. We can factor out an x from each term in this equation. So we get in the parentheses x squared minus 6x plus 9 equals 0. So we have a simple trinomial in the parentheses. So we can use the sum and the product rule to factor it. So we have to find two numbers that add to negative 6 and multiply to 9. So the numbers are negative 3 and negative 3. So the factored form for this trinomial will be x minus 3 and x minus 3 equals 0. So now we can solve for x by making the factors equal to 0. The first factor is x, so the first x value we get is x equals 0. Now these two factors are the same, so we just have to set it equal to 0 once. So x minus 3 equals 0 and we get x equals 3. Now we are already given that the function that the curve is touched by the tangent at the point 3, negative 3. So that point A is represented by the second solution we got. So x equals 3 cannot represent the x value for point B. So that means the x coordinate for point B is x equals 0. So now we'll use this x value to find the y value. So we can sub in this x equals 0 in the equation of the tangent or the equation of the curve. It's easier to use the equation of the tangent. So it'll just be y equals negative 0, which is equal to 0. So that's the y coordinate of point B. So point B is 0, comma 0. So that's the final answer for this problem. So these are the steps you have to keep in mind to solve a problem like this one. It's very important to understand that first we can find the derivative of the given function to find the expression for the slope of the tangent, and then we use the given point at which the tangent touches the curve to find the slope of the tangent at that point, and then we use that to find the equation of the tangent, and then we set the equation of the tangent equal to the equation of the curve to find their intersection points. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.